Welcome to a tutorial video on C++. In this video I'm going to talk about complex data types. As the end of this Learning C++ series, this video is going to be the culmination of a number of different videos and different complex ideas we've been dealing with across this series. In the last video I talked about creating objects. We talked about how there are blueprints and then we create an instance of that object and we can use it. We also talked about how objects follow the same grammatical structure as structs. That is, we talk about the object, a dot, and then the thing inside of it. We can use different functions and we can access different parts of that data. We also talked about in the previous video how objects have private areas and public areas. We can use the private area of an object to store its data. Then we can use the public area to define the functions that allow us to interact with that data in different ways. In this video, we're going to build off the last video and then jump into some new information. So first off, let's come down to person.h. As I reviewed in the previous video, this is the same file. There's one extra additional thing though. I've overloaded something down here and I've put some comments in here to define what I've done. This allows us to compare two different objects. And this is a more complex idea that I'm going to review, but you can, in C++, overload that is define new operations to allow you to do different things. In this case, I've defined something that basically returns if the ID and the name are the same. That is, if the ID and the name are the same between two different objects of the data type person, they are the same person. That is, they have the same ID and they have the same name. So it's just what this complex code is doing right here. But everything else about this looks the same as I reviewed in the previous video about objects. We have an ID and we have a name that are private. Then we have public interfaces, set ID, set name, get ID, and get name. So setters and getters, so we can interact with the private data that's part of this object. Moving on then, let's look at more complex data structures. I'm including two new things in this group.h file, the vector library and the algorithm library. The vector library is one of a number of different complex data structures C++ provides for you that you can include in your projects. A vector is similar to an array, but operates slightly differently. Because it is a more complex data structure, we have to use the vector library to use the vector data type. Similar to in the previous video, when I wanted to include the person object that we defined in the person.h file, I include that file. So vector data type is included using the vector library file. The algorithm library file defines different algorithms, ways of dealing with data. In this case, combining the two allows us to use parts of algorithm to work with data defined using vectors. It'll make a little more sense as we go through this. So in this file, similar to in the previous file, I'm defining a new class, a new object called group. It's defined just like I reviewed in the last video through open and closing curly brackets. Within all of this though, I'm defining a private area and down here a public area. So it looks just like person did, but the grammar is going to look a little bit different because it's dealing with vectors and algorithms. So let's scroll up here at the top. When we're dealing with vectors, we can say, hey, this is a vector of a certain type of data. Remember we were dealing with arrays, it got a little bit complicated when we wanted to deal with integer arrays and different types of arrays of dealing with those. So the way vector gets around this is it defines this sort of interface thing of less than and greater than signs around the type of data that's in the vector. So just like as I talked about in the previous video, I'm using a similar pattern here of collection is private, so it starts with an underscore. Collection is a private vector. It is a vector of what? It is a vector of people. People are based on the object person. So over here we defined the blueprint for person, and over here in group we're saying, hey, this is a collection of objects that follow the blueprint of person. So that's what we have right here. And I mentioned vectors are similar to arrays, but not quite. Now we're using right here an Iterator. An iterator is special functionality that is provided as part of the standard template library and part of working with vector. What it basically means is a thing that allows us to go through a data structure. It is, instead of using a for loop to move through an array, as we saw in previous videos, especially when we were looking at the looping structure, and we were able to loop through an array and assign it values. In this case, we don't always know what the data is going to look like, so an iterator allows us to define a section of data and also to move through that data using iterator functions. So basically, similar to how we were using for loops and arrays, we now have iterators and vectors. The same ideas, but slightly different wording and a slightly different grammar, but the same basic ideas. So an iterator allows us to move through things. Now, let's move down here to this first function. It can look a little bit confusing, but it works on the same ideas we covered in previous videos on functions. The very first thing is its return type. Well, what is its return type? Its return type is an iterator based on a vector containing objects of person. So that's what this means right here. This is an iterator of a vector based on objects of person, as I just discussed. So up here we said, oh, this is a vector of person. This is a vector of person iterator called IT. This function returns iterators based on vectors containing objects of person. Then we have a name, find person. Then we have its parameters, person p. So we're sending in a person, and it's doing something, and it's returning an iterator. Well, what this does is move through the vector and attempt to find that person in the collection. Collection is up here, defined as a vector. Remember I mentioned that instead of using for loops and arrays, or for loops to move through arrays, we use iterators to move through vectors. Same ideas. So in this case, we're using find, which is an algorithm, to look at beginning to end looking for p. This is a special function within algorithms called find. It's very helpful here, but it's based on a lot of assumptions that vector provides. As iterators, we can look at the beginning and the end. This is the functionality that vectors provide. They provide iterators for the beginning and an iterator for the end. So we can say, okay, moving from the beginning to the end, because remember, we don't know what the length is. We just know what the beginning is and what the end is. So moving from the beginning to the end, look for a person matching P. Now, the reason why, way back over here, we needed this extra code is for this operation right here. As it moves through these, it's comparing them, and it's comparing them using this operator. So if the ID and the name is the same, then they are equal. If not, then they are not equal. So using this special function to find an algorithm, using this functionality provided by vectors, we're saying, hey, can you find this? If you can, then return it. If you can't, just return the end. So notice right here it says, return either the end or the position of item if it found it. So this is a very quick way, right here using find person, combining functionality of vectors with functionality in algorithms, that we can just write a few lines of code that will search through the vector, attempt to find it, and return it for us, based on iterators and vectors. The same idea we saw with arrays and for loops. We could loop through an array looking for something, but in this case we can use more advanced functionality that does the same thing underneath the hood, but work through this in the same way. So we move from find person down here to the public interface. The very first thing we're doing is using a constructor. I didn't talk about this when we were dealing with objects, but if we want to set initial values, we can use a constructor. When a object is created, if a constructor function exists for it, it will run that first, and it allows us to set initial data. So what this does right here is we say, okay, this internal data, IT, which we know from up here, is private, and it's set to an iterator for a vector containing objects of person, set it to the collection beginning. So automatically set it to the beginning of that collection. Anytime we create a new group, the iterator should always be pointing at its beginning. Next, we'll say, okay, size. We need to know how many people are in this collection. We can call that using function size. And notice it follows the same thing, same conventions we've been talking about. Collection is an object, and we say object dot thing inside of it. In this case, the function size returns how many things are within the collection, which we define in this using our own function size that works on the same thing. So we're not dealing with collection directly, we're dealing with our public interface to our private data. Then right here, we're saying add person. We can send a person in, and it's get pushed back. Push back is a function that adds something to the end of the vector. So we say, okay, add to the end of the vector whatever person we pass into this. Again, a person is a blueprint of an object we've defined, and we say, okay, person, send in this person, we'll push it to the end of the list, and we'll add a person. Remove a person works for a very similar manner here. And we see we're calling our internal function find person. This is not external, this is internal. So we say whenever we want to remove a person, let's check to see if the person's in the list before we attempt to remove it. And if they is, go ahead and remove it. So we say, okay, this is an iterator of a vector containing objects of person called location. Location is equal to find person p. So whatever is passed into this function is set to find person. As we outlined, find person attempts to find it, uses the find algorithm to move through everything in the vector. If it finds it, it returns that location. If it doesn't, it just returns the end. So knowing that, we check down here. If location is not equal to collection.n, because remember, if it's not, then that means we found it. But if it is, then we just ignore it, and we just don't do anything. We silently don't do anything. If it's not equal to the end, we can use erase, which is a function as part of vectors, to remove that location, which removes that object from the vector. So we can add people to our collection, we can remove people from our collection, we can see how many things are inside this collection, and internally, we can create a function called findPerson, which searches through it and returns the location of any person objects within our vectors. So that's a little bit of complex functionality, but again, this is complex data structures working here. We're using vectors and we're using algorithms, but they're based on the same ideas I outlined in the previous video of functions, and based on the previous video of that on pointers and structs, and previous videos on arrays and functions. All of this all working together here to create a more complex project. So we have a group object. A group object holds a vector of person. Person is another object, and we can look through that using iterators and the functionality we've written here. So let's go all the way back to main. So we see similar code that we saw last time. To include person.h, we put at the top, and now we're including group.h. Group.h works with person, and we're including both of them here so we can use both. So you'll notice this is very similar code to the previous video, creating a new person object, setting its ID, setting its name, getting that ID, getting its name. Now we're creating a group object called set. Set that add person, Dan. Dan is a person object, so we can add to it. We can check how many things we have using set.size, how many are in this collection. The collection, remember, is a vector of person. Then we can remove Dan, and then we can double check the size. So I'll move this over and we'll run this. So as we saw, we set an ID, we set a name, the size is 1 when we've added Dan, and the size is back 0 when we remove Dan. So we've covered a lot of complex ideas in this video, most of which happened in this file right here. But they were based on things we talked about in the previous video. That is, we've defined a blueprint for an object, and now we've defined an object that works with that object. So we can define a person as having an ID and a name and functionality to change things about that person. Then we can find another object that holds multiple versions of the previous object. And so now we start to see the complexity that we can start to weave in C++ by creating our own objects that not only hold data and allows us to work with that data, but creating other objects that then can hold the previous objects. We start to see how we could build very complex projects this way. So we used in this file, in the group.h file, vector and algorithm, and I talked through how vectors are similar to arrays but slightly different, and how they look a little bit weird here. They use the less than and greater than around what they're holding, but it also allows us to look at this. I also talked about iterators as a way to look through complex data structures that C++ provides. They're basically just a location. They're similar to pointers in that way, as we discussed in a previous video, but not quite the same. They are locations within one of these complex data structures. So we have a collection of a vector that is a collection of objects of person. We have an iterator, so we can look at different parts of that object. And then we defined an internal function findPerson to allow us to look through these using find from algorithm. Down here we set a constructor, so whenever we build a new group, immediately set its internal iterator to the beginning of the collection. We can return the size of the collection, we can add people to the collection, we can remove people from the collection, and all of this interfaces, size, add person, and remove person, are obfuscated by the functions that are called. So we can completely change how this works internally, change it to a whole nother data structure, or even write our own. And it wouldn't really matter because the interface would remain the same. So part of working with complex data structures is that their internals can change as long as the interface remains the same. In fact, over here, when we used it in main, if we didn't know how add person and remove person worked, it wouldn't really matter. We could just send a person in and remove that same person, and the internals wouldn't matter to us. They would be black box code. That is, it would be completely opaque. We had no way of knowing what work is inside of it had we not written this code ourselves. But we can work with those interfaces and do different things, combining objects with complex data structures and objects holding other objects to build very complex, interconnected projects. And this is part of why C++ is so great as an ending to this whole series, is we can work with variables to hold data that can be inside of objects, that can hold other objects, that can work with complex data, that can work with algorithms to search through different things. We can combine all of these ideas and build very complicated projects based on the simple ideas of variables, arrays, and functions that we've covered in the first 3 videos. Building across those, we can start to look at objects here in these last couple of videos, pointers, and how we can combine those ideas, how iterators are similar to pointers, build all of those ideas together in one large project. Thanks for watching.